were you guys able to watch the experiment earlier at 1 p.m.? Yes, so we'll have a different set of science demonstrations for this afternoon. So My Moving Studio is where we show you guys some simple science concepts using different experiments and science activities. But before we begin, is anybody here visiting us for the first time? Oh, I think we're all first timers here. Anybody here who visited before? Second timers?
Tayo,
We
ito.
have a return visit. Anybody here visited us before the pandemic? Okay, so welcome guys. Welcome back to our return visitors and welcome to the first timers. Were you able to go around to the museum yet? Do you have any favorite exhibits so far?
What's your favorite?
Not yet. Will you have more time later to go around?
You listen to us.
Many fun activities to play with around the museum. For those who have gone around, what's your favorite exhibit? Yes, what's yours? The space shell. Is that the one where you can watch different films? There's Rex, a T-Rex, but our dinosaur actually has a name. Our dinosaur is named Stan. So Stan is a cast from a real dinosaur fossil, which is an actual T-Rex. So Stan is an actual fossil T-Rex, but not this one, it's just a cast. But did you also know that aside from touching the dinosaur bones there, you can touch real dinosaur poop? Ew, you don't like that? But don't worry, if you touch the dinosaur poop over there near gallery, it's already a fossilized dinosaur poop. So it's what we call coprolite. Don't worry, if you're gonna touch it, it's not going to make your hands stinky. It's already fossilized. Maybe this will give you a hint. He's popular with something to do with an apple. Yes.
Isaac Newton.
The one who, I'm sorry?
You say it. Raise your hand.
Okay, so this guy actually did discover gravity. He discovered gravity when an apple fell on him, but he discovered another thing. So another thing is actually, he discovered some laws that governs all the moving things in the universe. So who's this guy?
Isaac
Mr.
Newton.
Isaac Newton. And what are that three laws? What are those three laws that he came up with aside from gravity? The laws of?
Inertia.
It's something to do with moving, things that are moving around. It's your laws of? Yes. Physics says it has something to do with physics, but in particular it has something to do with motion. So it's your laws of motion. So, does anybody know how many laws of motion we have? How many laws of motion was Sir Isaac Newton able to come up with? Yes. There are 3 laws of motion. Very good. So for this afternoon, we will be going through the 3 laws of motion with some activities and some puzzles here with us. I have here the first one. Is anybody familiar with the first law of motion? No? It's the law of motion that states that an object at rest will remain at rest, and an object in motion will stay in motion unless another force does something to change the way it's moving. So for example, if I just leave this ball here, it's not going to move unless I push it, and it's not going to stop until I put something to stop it. Okay, so if I let this ball fall, it's going to keep falling until it reaches something that's going to stop it from falling. And what's that force that keeps it falling? That's gravity, correct? The one that also Sir Isaac Newton was able to discover with the help of an apple. So for the first law of motion, it starts with the letter I. Can anybody give me the first law of motion? It's the law of inertia. That's correct.
Miss Lucy.
So for the first law of motion, I have here a little challenge for you guys. So my challenge is, how do we keep this ping pong ball inside this bucket even if I flip the bucket over?
Miss Lucy.
So if I just flip it like that, the bucket will fall, the ball will fall from the bucket. So how do I do it that the ball will still remain in the bucket even if the bucket is upside down? Anybody have any guesses? Or anybody want to give it a try? Okay, maybe you can give it a try. So how do we do it that the ball will remain in the bucket even if it's upside down? You put something to cover it, yes, but we want to do it in just one motion. You just want to do something to the bucket, not cover anything with it, just the bucket and the ball. You have a guess as well? Maybe come here in front, want to do it?
Later, look at that.
So how do we do it that the bucket will be flipped, but the ball will remain inside? Okay, very good. How did you do that again?
I just spin one pump.
Spinning the bucket like a Ferris wheel. So will you spin it very fast or slow?
I will try doing it fast.
Okay, right, very good. So why the B? Thank you so much for being volunteer. So why the B? Ball remain inside the bucket. If you do it like that, the ball is just going to fall. But when our volunteers spin the bucket around, they can actually do it multiple times. The path that the ball and the bucket are following, the circular path, they want to remain following that path. Okay? So if you want to go here, if the ball wants to go here, the bucket is also going there. And they want to remain on that circular path, but the bucket keeps on catching the ball inside. So do that. You can actually do it many, many times. You can even do it as long as you do it quickly. The ball will remain inside your bucket. Now that we can prove that inertia works on your solid, do you think it will work on your water, on your liquid? We have a few believers here of science who thinks it's going to spill. Okay, we have a lot of doubters as well, so I choose to believe Mr. Isaac Newton with this one. So I hope everyone here has a spare set of clothes here in front. That's a joke, I'm not going to spill anything on you. So let's try to make it work with water. I'll spin it in 3, 2, 1. Okay, let's do it one more time in 3, 2, 1. Okay. So the similar thing happens, the motion is still circular motion, and everything that I'm holding wants to follow that circular motion. So even if it's water or solid or liquid inside your bucket, the bucket is still going to catch the thing that you spin it around with. You can use that. You can maybe do it at school, show you guys the law of inertia. Okay? So that's our first law of motion. We can now move on to the second one. So what's the second law of motion? It's actually written here around the demo area. It's your law of acceleration. Okay? So you can see over there, there's an equation that's written as F is equal to ma. Over there, F is equal to ma. That just states that the higher the mass of an object, it would take a lot more force for that object to accelerate. And for that demonstration, we have here, I'm just going to set it up for you. It's a glass, but it's just a plastic cup of water. I have a paper plate, I have a tissue roll, and an egg. So can I please get a volunteer here in front of me? Okay, maybe you can join me here in front. Okay. So before I set up the second one, can you tell me which is lighter between the two? This one, but are they both light? Yes, okay. So if I give you this one, which is heavier among the three? This one is the heaviest. So these two are lighter compared to this egg. So among the three, which one would require a much greater force for it to accelerate? The egg, right? Because it's heavier or lighter than your other objects? It's heavier than your other objects, okay? So for our next challenge, is in one motion. How can we make the egg fall down to the cup in just one motion? You want to take a guess? If you do it faster, what motion would you make? Does anyone have a suggestion that we can try? Remove the plate? How do we remove the plate? Sliding it? Maybe you want to give it a try? You want to give it a try on the other side? Okay. Okay, thank you so much for doing that. You can maybe give it a try over here. Okay, very good. Don't worry, it's okay. Thank you. Thank you so much for being. So how did we make the egg fall down to the cup in just one motion? We pulled the plate. Did we pull it fast or slow? We pulled it fast, right? So when we pulled the plate and the tissue roll, only these two were affected by the motion that we made. Because again, the egg would take a much greater force for it to move. So instead, it stayed there and only moved downwards by the pull of what force? Gravity again. But it wasn't affected by how we pulled the plate to the other direction. Okay? But there's another motion that we can do to make that egg fall downwards. If we fold it, do you think it's going to work if we push the plate? You think it's going to work? It won't work? Okay, let's see if we can make it work by just smacking the plate into one direction. Okay. It worked as well when we smacked the plate to one direction because again, only the plate and the tissue roll core was affected by that motion and the egg only fell down because of gravity. So again, heavier objects need greater or less force to accelerate? Greater force. Okay? So that's your second law of motion. So our third law of motion may be the most familiar for us all. It's the law of action-reaction, of the law of interaction. Can anybody tell me what it is? Yes.
Conquer. Conquer.
Sorry.
Conquer.
Conquer. But this is a pump, but what is the third law of motion? Yes.
If two objects are colliding against each other, they will both feel the force.
Yes, that's one interpretation of your third law of motion. If there's two objects that are colliding, like your hand or this one, you will both feel the force because the third law of motion states that for every action, there's an equal and opposite reaction. So for example, when you smack the table, does it hurt or not?
No.
It will hurt a little bit, right? Because the table is also exerting a force in your hand. So even when you high-five someone, the action will create an opposite reaction and that will cause a little bit of a sting to your hands, to both of your hands. And one of the best examples to show the law of interaction are actually your rockets. Okay? Yes, we will try to make a rocket fly using the third law of motion. So what do you see that's coming out of the rocket when it flows up to the space? There's fire, right? There's a combustion that's happening at the tail of the rocket. Okay, I'll show you later. Okay, we actually have a few. I will try to not make stuff this time. So we are going to put a little bit of water inside our bottle. This is just a PET bottle. And, move that.
Bella, look at the rocket. Kita niya? Tingnan mo nga. Kita ba yan? Buhatin mo na lang.
So what I'm going to do is I have this rocket filled with water. I'm just going to put the stopper on the rocket. Okay. And when we pump something inside, what happens to the pressure inside the rocket? It will increase or decrease? It will increase, right? Because there are a lot more things inside your rocket. 1, 2, and